Okay, so here's example number 2. The university admission director states that the average, so as soon as I see that word average, that's a mu. So I know I'm doing either t-test or z-test. So here is my original claim, is that the average ACT score is 23. To test this claim, you randomly select a sample size of 30 students, which has an average ACT score of 24.1. You visit the ACT website and find the population standard deviation is 4.8. So we know it's a test for means, so it's either going to be Z or T. So what it comes down to is whether or not we know the population standard deviation, and we do. So that makes this a Z test. So my null and alternative, I have H sub O, H sub A. Because we're dealing with means now, that means we should be using mu. H sub O is the original claim. Always use equal sign for H sub O. So my original claim is that the ACT is 23. Now, one of the things that I want you to be aware of, even though we got a sample and the sample came out greater, that does not mean you choose greater. Unless there is specific language to say, we think that it is greater, that's when you would choose greater. If there is not that specific language there, then you just choose not equal. So null and alternative, mu is equal to 23, alternative, mu is not equal to 23. So this is a two-tailed test again. Again, unless they say otherwise, alpha is going to be 0.05. So critical value and test statistics. So this is where I'm going to my formula sheet. Two-tailed test. We should remember this from the last example, but just in case. Second vars, inverse norm, alpha divided by 2, 0, and 1. So 1.96. And because it is a two-tailed test, we're going to have negative 1.96 and positive 1.96. So we have two separate reject regions. Okay, so now what we have to do is find our test statistic. So here's my formula for test statistic because I'm dealing with means. So my formula says we're going to do the sample mean, which was 24.1, minus mu, which was 23, divided by sigma over the square root of n. Okay, so I got 1.36. So just to remind you, test statistic and critical value. Your critical value tells you how many standard deviations you can be above or below the mean and still be considered acceptable or normal. And then your test statistic is based on your sample, how many standard deviations are you actually above and below the mean. And we're basing this all off of a standard normal distribution with 0 in the middle. So we were 1.36 standard deviations above the mean. To be unusual, we had to be 1.96, so we didn't get there. And remember this shaded area, this is where you get to reject the null. So that means this unshaded area, this is our fail to reject region. So based on this step, we are failing to reject. So now we want to find a p-value and see if that supports the same decision. So going back to our formula sheet, I'm going to go to normal CDF. I'm going to use the absolute value of my test statistic to infinity. So I get, and I have to multiply it by 2 because it's a two-tailed test. So I get a p-value of 0.17. And remember, the whole idea here is If your p-value is less than alpha, you get to reject. So we are comparing 0.17 to 0.05. Some people get confused on the decimals, so think about it in terms of percentages. Is 17% less than 5%? No. So both of these two steps support the decision of failing to reject. Okay, so we fail to reject. That means we do not have enough information to reject their claim. So we're not outright admitting that we think they're right. We just are saying we don't have enough information to reject it. So now what we're going to do is we're going to calculate our confidence interval. So since we ran a z-test, we are going to run a z-interval to go along with that. So stat test z-interval. Sigma was 4.8, X bar was 24.1. We had 35 students. So I'm going to say 22.5 to 25.7. So the interpretation would be we're 95% confident that the true mean ACT score of entering freshmen is between 22.5 and 25.7. So how does that support the same decision? The reason that it supports that same decision is because hopefully what you will notice is 23 is in that interval. So because 23 is in that interval, is there a chance that it could actually be 23? Yes, there is, which means we can't reject 23 because it is possible it could be 23 since it's in the interval. Okay, so that's an example of a z-test.